So let's get started. I'm going to be talking about a topic which maybe you haven't thought about before. Most of you probably have a lot of data. And well, some of you maybe not if you have a small shop. Anybody here have a database that's larger than 5 gig? Whoa! You had a lot more than yesterday. In yesterday's session I asked that. Only had a couple people raise their hand for 5 gig. How about people here have larger than 10 gig? Whoa! That's way more than yesterday. You're a completely different group. So I don't even ask anything smaller than that. Well, just a few people had that larger databases. So what we're going to talk about today is dealing with large amounts of data and what some of the options. I'm not going to cover every possible thing there is. There's all kinds of options you can cover, but in an hour I can only cover a few things. And I'm going to focus on basically the option of using compression, both at the database level and of course the backup level is some of the key things. Obviously other things you can do too, but I only have an hour to talk about. Here's some interesting statistics that I found when I was doing some research. In 2010, apparently, there's roughly 1.2 zettabytes of data were created that year. And a zettabyte is 1 trillion gigabytes. And in 2011, it went up to 1.8 zettabytes being created. And according to their projections, who knows how accurate it is, by 2020, another 50 times data. And that's only 8 years from now. I imagine 8 years from now, most of us will still probably most of us here will still be DBAs. Can you imagine 50 times more data than you have right now? That's a lot of data, isn't it? Just imagine that. How are you going to deal with all that? Have you figured that out yet? Hopefully you have, because, or at least you're thinking about it, because your CEO and your CFO and your CIO probably aren't thinking about it, because they're just thinking of production databases, you know. They're not thinking about anything else. They're thinking about what's happening right now, not in the future. And if this kind of trend occurs, which I'm sure is going to occur in most companies, I'm going to figure out a way to deal with it. And I can't answer all your questions, but I'm going to try to answer some of them. So why is data growing so fast? What are some of the reasons? And this is also getting according to a survey. And some of these are pretty obvious. Business growth, and even though the world's been more or less a recession for the last number of years, still most businesses these bigger businesses are increasing revenues, not necessarily increasing profits, but the number of transactions are going up. That creates more data. So obviously that's one of the more obvious things. Business acquisitions, of course, most of you are familiar with that. I used to work for a company that bought other companies all the time, so I spent a lot of my time taking data and taking it and moving it into our data center. Sometimes we merge the data, sometimes we just add more databases. It depends upon a situation. And so we're adding data constantly. I can't remember, when I started out, we only had 5 or 6 SQL servers, and then when I left, we had 40 or 50 SQL servers. I can't remember how many databases, I lost track of those. But and I was the only one doing that stuff. And we just grew very fast, mostly in our case because of business acquisitions. As you know, data warehousing, that kind of analysis, everybody wants that now. And of course, in this case, what we're happening is we're taking data that exists in LTP databases, and we're often aggregating it, basically changing it to a different form and store it in another database, essentially a copy of a copy. Right, so we have the original and we have other copies of it. And of course, more and more people want that, and that's actually increasing a lot of the data. Other ones, reporting from core business systems, I think that's kind of related to the OLAP one. But basically, people wanting more data in more forms, so they're taking basic data that we have now, maybe gathering other data. Let's say, for example, maybe we have sales data we're keeping track of, but now we want to add Google Analytics data from somewhere else. We're going to bring that in and then use that for more reports. So that'll be an example where we're getting more data. But actually, we can, in a sense, duplicate it. It already exists somewhere else, but we want to bring it in-house for our own use. Business protection, that's pretty obvious. Yeah, everybody knows about that. And then obviously it duplicates data a lot of ways. Another thing too, which is kind of a new trend, in the past, and when I say past, like the last 20 years or older, many times when you had data was stored in tape, long term. And of course, it basically wasn't really online. If someone needed the tape, they went to tape, they loaded it, they got the data they wanted, and they took the tape away and whatever. Well, more and more businesses now want everything online. They don't want to go back and get a tape because a marketing analyst may say, I want to analyze the data for the last 10 years or 20 years. And the only way they can do that, of course, is by having it online. So what used to be offline now is becoming online, more and more of a tendency. So again, another reason data is growing and we have to manage it all. How many people here regularly delete data never, permanently? Anybody? Nobody raises a hand. That's very rarely done. You might occasionally archive it, and even then that's a pain in the neck usually, but it's usually just easier to leave it in the database or maybe move it over to a data warehouse or something like that. But you rarely ever get rid of it. Obviously there's government reasons for keeping stuff, all kinds of rules about how long you have to keep it. We're also storing different kinds of data, bigger data. Again, right now isn't the biggest database in the world Facebook, if I remember right? And part of that is because, again, a lot of it they store the images and videos and everything else. It's even bigger than YouTube by quite a bit, if I remember correctly. So we're storing more kinds of data, not necessarily inside the database. But in SQL Server, of course, that could be in file stream, where the new file table options, where it's actually stored in the file system, but managed by SQL Server. But it's still part of the data that we manage. And when we do a backup, we have to back up both. Because, again, we have to, obviously it has to be all kept together. And there's many other reasons. So again, this is not going to stop, right? So what are we going to do as DBAs? How are we going to deal with this issue of this tremendous growth? We don't have much control over the growth, right? We can't just go to our CIO and say, sorry, we don't want to do more data. It doesn't work that way, right? They're going to say, here, we want this. You figure out how to do it. And of course, you're going to have to come and say, this is how much it's going to cost, boss, and go from there. You all know about that. But of course, there's different ways of trying to cope with that. In other words, yes, we have this problem, we have to deal with the data, so what can we do? And there's some options of things that we can do actually today that are actually fairly straightforward and simple, and some of you are already doing it. For example, if anybody here is doing backup compression, you're already doing some of the kinds of things I'm talking about, because that's one of the easy, low-hanging fruit, is what I'm calling it up here, of what we can do right now to save data. And we'll be talking about that more later. But I'm also going to be talking about actually compressing other kinds of data too, because compression is a cheap way to get space right now for relatively inexpensive and for very few downsides. Everything, like anything else, it's pros and cons, but for the most part, compression can be very advantageous and something that we can do right now today and save us money today and, of course, save us money in the future. But a lot of us don't think about compression, though, other maybe than backups. They don't think about compressing their databases because it's kind of a foreign concept. It's not been around a long time. And also, some of you may have heard of NTFS compression. And you never want to use that in SQL Server because they don't cooperate together very well. It's not designed. So you have to have compression that's designed to work with SQL Server. So compression, in many ways, kind of got a bad rap and reputation in the past. But now, with the way Microsoft has designed their APIs to make it easier for vendors like Redgate and others to create applications to work with the operating system to compress data, makes your lives a whole lot easier. We know the data is going to be reliable. So one of the biggest low-hanging fruits that I think about is duplicate databases or duplicate data. I kind of use those words interchangeably, even though they're slightly different. A duplicate database would be like an exact copy. Here's production, and you have exact copy for test or development. Duplicate data would be you have OLTP data, and then you somehow convert it to an OLAP database. So it's a different database, maybe in a different form, but it's still duplicate data. So that's what I'm referring to. According to one industry study, on average, each production database has an average of 7 copies within the organization. And that's not backups. Backups are actually a separate issue. But that's kind of a big number if you think about it. And if you think about your own company, I'm pretty sure most of you can think of 1 or 2 copies of your production databases. But some of you probably don't even realize you have that many copies. And that's maybe one of the things I want to challenge you to is when you go back to work next week, look at your production databases and try to find out how many copies do you have. And I'm going to be talking about where you might find them because you may not think about where they might be. And I'm going to talk about some places to look for them. And because, again, when you actually look at it, there's actually more data storage devoted to the duplicate data than there is to actual production data. And there will be. It's never going to change as far as I know because you need that duplicate for a variety of reasons. So we're going to be talking about that. Here's a bunch of examples of where you might find that duplicate stuff. You might not even think about it as being duplicate. Backups, of course, that's the most obvious one. Some people keep a couple backups, some people keep 14 backups, some people keep 30 backups, some people keep backups indefinitely, do one every day and keep it forever. So it depends on how many backups you make. You can store a heck of a lot of data really quick. So that's one of the more obvious ones. And that's what people are dealing with now already quite often. Database snapshots. Anybody here doing snapshots at all? Oh, well, you have much more bigger audience than yesterday. I don't know, one person raised their hand yesterday in that one too. Again, duplicate data. Log shipping. How many people log ship? A whole bunch of you. Again, obviously you're going to have the original one and you're going to have the log shipped one. That's obviously double the data right there, let alone anything else. How many people mirror? Yeah, same thing. You have to have 2 copies. How many have tried 2012 Always On yet? Anybody? 1 person? 2 people? Okay. Of course, very similar to mirroring, but now instead of just having 1 copy, we can have multiple replicas. So instead of having 1, we could have 3 or 4 or 5 of them we want to, and this thing, even more copies of our data. Yes, Microsoft's making, I guess maybe Microsoft owns a lot of stock in storage companies, you think? You probably own EMC secretly or something like that, so Wishing Digital or whatever. So every time they come out with a SQL Server, they're making more money by selling more storage, who knows? Something to think about. How many people are doing sand mirroring and snapshots kind of thing? That's duplicate data. Again, obviously the way of backing up is important to do it. It's part of your HA abilities. But again, more duplicate data. Image backups, for example, like ghost backups. That's not commonly done to purposely back up a SQL Server database, but it's often done, for example, where I used to work, every time before they made a modification to server, like a service pack or whatever, they stop the machine, image it, and then make the changes. That way you could always roll it back. But they kept the images. So when they have 200 servers in their server room, you had 200 images that all store data, which again has to be stored somewhere, right? And usually ends up being in some SAN or some NAS device or something like that. Reporting, and in that case what I'm talking about is where you take maybe a production database, copy it to another server, and report off that rather than the production database. A lot of people do that as a cheap way to replicate their data. And this one you might not think about because it's not permanent, but it still takes up space. If you're in a situation where you have to import or export lots of data, and a lot of people do that literally every day, tens of millions of rows or billions of rows a day, that while that's always moving, but during that temporary time when it has to be on disk as it's moving, it takes up space. And so in a sense, it's also duplicate data. And that can be compressed too. A lot of people aren't aware that that can be done. And actually not only compresses, it can speed up importing and exporting the data quickly. And then your standard for development and such. Hopefully everybody has a test database of their production database, whether it's a third-party vendor or something wrote in-house. Hopefully you have a test, at least on your desktop, if not on a formal test machine, another copy. Of course, if you do your own development, which some of you may or may not do, you're going to have at least 1 development database, and depending upon the company, every developer may want their own copy. You have 10 developers, they may want their 10 copies of a production database, have their own little thing, you know. But I know developers tend to like to have that kind of thing if they can get it. So again, copies all over the place. You may not even know what kind of copies they have out there, because you may give it to one person, he may share it to that person, this person, you may not even know they're out there, but they're all out in their system. And some people have staging databases, some people have QA databases. Those are other examples that people run across. Replication. How many people here use replication of some sort? Again, in that case, of course, sometimes you might replicate the whole database, but in most cases you replicate part of it. But again, you replicate it, you're going to have this distribution database, which is another database, and then of course you're going to have all the subscribers. And you might have 1 subscriber, you might have 1,000 subscribers. And just think about how often that data is duplicated over and over and over again. I think it's becoming less common than it used to be, because now it's so much easier on the internet to go to one central source. In the older days, it was a little harder. You didn't have access to the internet, or you didn't have fast internet, so replication is more commonly used, where they would every day, like for if you had a franchise operation, it might be replicate once a day, like your inventory or something like that. But now it's less important. But it's still a common thing that people use, and we duplicate data. Here's another one you might not think about: training. If you have an in-house app or any kind of app used in-house, you have to train your employees, right? You're probably not going to train them directly on production. You're probably going to have a copy for training purposes. Again, another copy of the database. Some people use archive. When I talk about archive, what I mean there is you may want to keep it online, the old data, but you also may want to still keep it separate, archived for whatever reason, another physical location, but it still has to be stored, right, somewhere. And you may, one option would be to have your own duplicate data center or archival area, or you may rent one, but still cost you money, and they usually charge you by space, right? Another one that's interesting is litigation. You know, people don't like to be sued or get sued all the time, and they have to have the data to back it up. The company I used to work for, they had basically most of the system on an IBM mainframe, and have been there for years and years and years. They had like 30, 40 years of data. I mean, they started out in the early 60s. So they had tons of data on their mainframe, and they decided to move to an ERP system, actually SAP. And so they spent millions and millions of dollars and building an SAP system, moving everything over, and it was just a couple-year project. Then they got sued by the federal government for antitrust violations. But now all of a sudden, because of the litigation, their mainframe, which they were hoping to get rid of because it was so expensive, they can't get rid of. Because now the data is in that old format, and the government says you can't change it. Yeah, you've moved it over. We don't want that. We want the original data. So now they have to maintain two complete systems for years and years and years while the court battles go through. I don't know what's going to happen there, but now they spend a huge amount of money. So some people are just doing it automatically. These guys were not doing it very willingly because, again, maintaining their mainframe was very expensive. So it's basically just sitting there for legal purposes. It's not even being used on a day-to-day basis. And of course, other various government compliance purposes. But isn't data cheap? Storage cheap? In other words, what the heck? You know, if it is growing, why don't we just buy more hard drives? And actually, that's the main reason. According to another survey, the most common way organizations deal with lack of storage is to buy more storage. That makes sense. So what's the big deal anyway? So once we just buy more storage, isn't the cost per gigabyte going down? Well, it is. But what's not going down is the total cost of storage. Because when people think about storage, they usually think, oh, the cost per gigabyte of the drive. You know, as we've gone from a 100 gig drive, actually the very first hard drive I ever saw for a small computer was 5 megabytes. And it cost $2,500. And it was back in 1982 for a PC. Now, of course, you can buy 2, 3 terabyte drives, whatever, for a couple $100. And everybody sees that and thinks, well, storage is really cheap. Of course, that's not server class storage, that's home class storage. When you get to server class storage, it's a lot more expensive. Still, the price per gigabyte is going down on the drives, but people forget about there's actually a whole ecosystem of costs associated with storage besides the drives themselves, and many of those are actually going up in price, not down. According to some research we found, actually from some of it was from Gartner, and actually some of it we conducted at Redgate ourselves, is that on average, for people who have high-end SANs, typically the actual cost for usable terabytes is between $5,000 and $10,000 per terabyte. That seems high, doesn't it? When you think of, oh, I can go down to a store and buy it, you know, for $100. Well, the drive, of course, these drives, of course, the 15K drives, the high-end drives, the drives themselves may cost $400 or $500. But then if you get all the other pieces, for example, you have cabinets, you have controllers, you have cables, you have racks, HBAs, switches. These are all things that have to be added incrementally. Of course, sometimes if you have it already there, you can add for a while until you run out of space, then you have to add another cabinet and start all over again. So it kind of jumps and cycles. So some of your terabytes may be a lot cheaper, but some of the next terabytes are a lot more expensive. It can become where you jump. But then a lot of times consulting installation costs. Most companies that I'm aware of, unless you're a very big company, you don't have a full-time person who can basically knows how to install a SAN. Basically, your vendor does it for you. And they charge you a lot of money. They charge you a lot of money to sell you the SAN. They charge you a lot of money to install the SAN and any consulting associated with it. That's actually going up. That's not going down at all. Your maintenance costs for your hardware. You have to buy SAN, you have to buy a maintenance contract. There's no other way around that. Anybody know anybody whose price of maintenance contracts have gone down lately? No, they go up, don't they, pretty regularly. So again, it's actually increasing. Also software, because in SAN you have to license the software. And it depends what software you license. Is that going down? Is the cost of support for that going down? No, it's all going up too. Oftentimes extra staff. A lot of people have local SAN administrators. Are SAN administrators inexpensive? No, they probably get as much or more than DBAs get. And they're a lot more arrogant than we are, aren't they? I'm sure there's no SAN administrators in the audience, right? Again, and just the obvious stuff. Electricity, cooling, physical space, these are all costs. So that's why the actual usable cost of a terabyte ranges from $5,000 to $10,000. People don't think about that. So it's actually a lot more expensive than you think to store data on a high-end system. If you're a small business, you want to buy a $200 or $300 large USB-based hard drive for backup, that's cheap. But most of you probably don't fall in that category, I would imagine. Especially these guys that have multiple terabyte databases. You're not going to, even though you can fit them on one of those drives, you're not going to probably run your business on one of those drives. So you can probably buy the expensive stuff. So how can we save money? Well, again, we can't control how much data we're going to actually store. So one of the, as I said before, some of the low-hanging fruit is this data duplication, either from backups or from other reasons we talked about, and actually to compress it. Compressing is one of the cheapest ways we can deal with it. And again, a lot of us haven't thought about that a lot because we're not really used to it. So that's what I want to focus on, because compression is much cheaper and much faster to do and implement than getting a new SAN. For example, let's say in a situation where you're borderline where you're going to have to get a SAN in the next 6 to 12 months. Now you start budgeting, you look at the cost, you're getting bids, you're seeing $500,000, $1 million being quoted. And what would you think if we're spending just a little bit of money, you could now compress all that data by about 70% or so, 80%. Now all of a sudden you don't need a SAN anymore, at least not in the next 12 months, maybe 2 or 3 years from now, but you can delay that cost a lot longer. So that's what I'm talking about, is in this particular example, is some of the easy, low-hanging fruit that you can do right now, today if you want to, and of course in the future. And well, I mentioned before there's a lot of duplication. These are the specific areas where I consider compression being very feasible. Now, compression can be done on databases that are production databases, or it can be done on non-production databases. My recommendation is that when you start out, if you decide to use compression and start considering it, start with your non-production databases, the ones with multiple copies. Because that gets you comfortable with the technology. Because compression is still a new technology for SQL Server. So a lot of people are a little scared of it. They say, oh, it may not work right, or I might lose my data, or may get corrupted, or whatever. Well, in the past that may have been true. It's no longer true. But again, I know you need to convince yourself of that. So start out with production data and start compressing that. And at some point, when you become really comfortable with it, then start maybe even consider compression even for your production data. It's up to you. But these are, again, some of the obvious ones that I came up with where I know compression can work today very safely in essentially non-production environments. I guess maybe a replication might be considered production, but again, if it's a subscriber that's being compressed, it's not a big deal. It would have a problem, but again, I don't imagine you will. But those are some of the obvious ones that I would start with first. I'm sure all of you have one or more of these categories of duplicate databases in your company that would be prime candidates for compression. And of course, the product I want to talk about here briefly is SQL Storage Compress, which is a neat little tool. I've been playing with it a lot at home and doing a lot of testing on it myself, because like you, I'm a little dubious. DBAs, you know, should be doubting Thomases. We shouldn't believe what people tell us. We shouldn't believe what the vendors tell us. We should always test things for ourselves. And I've been doing a lot of that myself. SQL Storage Compress is kind of a unique product. On average, it compresses about 73%, sometimes more. And what's really interesting is all the compression is done outside of SQL Server. It's actually done as part of the operating system. It's actually, what it does is installs a service, just like any other Windows service, and into the Windows operating system. And then what happens is it works all in the background. So when SQL Server itself, when it tries to read or write data, it doesn't actually physically read or write data. It basically says, hey, operating system, would you read or write data for me? And the operating system has something called the Windows I/O Manager, which does all the work. And what happens is Microsoft has created an API that anybody can use. For example, antivirus vendors use this API. And we're using the same API, so when data moves back and forth as it's read or written from the operating system, we can grab that data via the API and compress or decompress it on the fly. Because when we do it that way, SQL Server doesn't even know what's going on because SQL Server is a different layer of the stack. So it's completely invisible to SQL Server. So a lot of times when people install SQL Storage Compress and start using it, they say it's not working. Because they go to Management Studio and they look at databases and the size is exactly the same size. That's because SQL Server thinks it's the same size. That's because it's all the fooling, the magic is happening at the operating system level. And I'll show you an example of that here shortly. But let's get an example of the kind of money you might be able to save, depending on your example. Let's say you have a 1 terabyte production database, and you might happen to have 5 copies of it, duplicate. I just made that number up. It's even less than the 7 average from that research study. Just make my numbers easier to calculate. If you assume that average 73% production, you can turn that 5 terabytes to 1.35 terabytes, save 3.65 terabytes, and assuming that other number we saw, we could save $15,000 to $30,000 just right away. Again, obviously, there's a lot of assumptions being made there, and your situation will be different. But the numbers may be different in your situation, but they should be very similar in terms of cost savings right away. And if you do this kind of analysis over an entire organization, I think you'll see right away how much space you can save up. You'll be actually probably impressed. Another thing you can do too, for example, is say development databases that are now large, and maybe they're on a SAN now because they're so big. Well, they can be compressed and actually put on the local developer's hard drive. And now you get to actually move it off the SAN and now free up all that space in the SAN, put it on cheap disk space. This is an example. I want to give you a little example of how kind of savings that you can get. First of all, I'm going to show you my machine. This is in a laptop, obviously. And I have 2 drives. Actually, these are SSD drives. The first one basically has the OS on it, my applications, these for all my data. Notice this particular drive has 238 gigabytes total capacity, of which about 133 are available. So about half my drive is full right now. Okay, that's pretty straightforward. But now let's go to Management Studio real quick. You notice I have a bunch of databases. The ones I want to focus on are these. I have 5 databases. They all have similar names. And I created these databases for another presentation I do. That's why the names are very similar. What I did is I actually created one database initially, which was 100 gigabytes in the MDF and 20 gigabytes in the LDF. Right-click and show you that. Should prove that I'm not cheating, not using any smoke and mirrors. Again, you have 100 gigabyte and 20 gigabyte. And what I did is then I made 5 copies of it. So 120 plus 120 plus 120, I got to 600 gigs. Okay? I have 600 gigs in these databases, not even counting these. But my hard drive, again, is, where's my hard drive at? Is only 238 gig. And it's only half full, but I have 600 gigabyte databases on it. How can I do that? Well, I have SQL Storage Compressed on my machine. So I'm getting a huge amount of database space on my machine because I have compression going. And now to prove it, let me go to where the data's at. And let's look at the actual files. MDX, 965 meg, not 100 gig. Over 90% compression in this case. That's actually unusual. 73% is more the real number. This is kind of a test data, so it's not normal, typical data. So I get even higher compression. But still, that's the point I want to get across, is how much savings you can get. Notice the 20 gig LDF is now 1.4 megabyte. So a compression can save you a lot of space. Again, this is being again, a little unusual, but again, it's a huge savings. Okay. Yeah, okay, that's a good point. I was actually going to bring that up next. As you probably know in SQL Server, what you call a database is really irrelevant. This first name obviously is irrelevant. And even this last name, whether you use MDF, NDF, or LDF, SQL Server doesn't care. Those are just common designations we all use because it makes life easier, right? So we know what it is. So what we did is we have to be able to differentiate what databases we want to compress and not compress. And there's various ways of doing it, so we decided to add an X to the end of it. So that way, when you add an X to the end of it, SQL Storage Compress knows, oh, I need to compress that one. And that's what it does. And that's how it knows the difference. And you can choose, for example, to compress the MDX, but not the LDF, if you want to. Sometimes, for example, if you want to use this in production on a very busy system, generally we recommend not compressing the LDF, but only compressing the MDF. But in a non-production environment, compressing both of them works fine. So as you can see right away, it can save a lot of space. And it's kind of an amazing thing. You can get a huge amount of data stored on a system like this by using compression.
Have you tested this on CRM, for example, Microsoft CRM?
No, I've not personally tried it in CRM, but can't see why it wouldn't work, because everything's done in the background in the operating system. The application and SQL Server does not know what's going on. It's completely hidden from it.
Is there a performance impact?
That is the next thing I was going to mention. Is there a performance impact? Of course there is. Anytime you compress anything, it's going to require additional CPU. For example, even Microsoft has its own page and a row compression. Of course, when you turn that on, CPU goes up. It's just a requirement. Whenever you compress something or decompress something, it requires CPU. Based on our testing, typically the CPU increase is about 0.5%, typically. So it's very minimal. Yes, sir?
Brad, we use storage compression.
Oh, you can.
Actually, that we're getting better performance of bringing large volumes of data in, is actually the amount of data in bytes that we're bringing in is greatly reduced. So actually that takes less time to actually transfer that data across.
Exactly. So that was the next thing I was getting to. Everybody's reading my mind. So yes, so there's a very slight increase in CPU. So that does go up, but it's very minimal. And unless you have a system that's already CPU bottlenecked, you're not ever going to know the difference. But another advantage is that because the data is compressed, your I/O is reduced. So you get that benefit. And it can be reduced by quite a bit. It depends upon the nature of your workload. Sometimes you get bigger benefits than others. So yes, what basically I found out is that sometimes the product is faster than regular SQL Server. Sometimes it can be a little slower in SQL Server, and sometimes it's exactly the same. Based on my experience, the difference vary depending on your workload, and on a machine that's not bottlenecked, you will never notice the difference in performance. If you have a machine that's heavily bottlenecked in all areas, you might see a problem. Of course, actually in some places, if the bottleneck is an I/O, then you actually see an improvement. But the bottleneck's the CPU or maybe memory, then you might see some performance degradation. So again, yes, there's implications in performance like there isn't anything else. There's no free giveaways, no free lunches. You always have to pay for something. So again, that's something you have to consider, and that's why we also always recommend that you start out in a non-production environment so you get a feel for how your particular apps work. And then when you're happy, you know this working correctly, performance is not going to be an issue, then start maybe considering moving it into production to save you space. But again, you have so much you can buy right now non-production data, you're well on your way to saving a lot of space. Yes?
You've been saying this about going on into the production applications and the knock-on effect.
Mm-hmm.
Have you seen the knock-on effect onto a migration databases where you're migrating that, your example of bringing data from an IBM mainframe data onto the SQL Server?
I've not tried that particular situation, but I would not see any major differences. If you're moving data from a mainframe to SQL Server, obviously when you import the data, the compression is going to occur at that time. And then the data will be compressed, and again, I don't see...
Time analysis, the migration time, and what is the time analysis on the compressed one?
Well, that's complex because you have two sides of it. You have the IBM side, for example, you're moving it down, and you can't affect that. The only thing you're going to affect is when you move it into SQL Server. And the first time you move it over, it's going to take it from uncompressed to compressed, so it's going to be a little bit more of a hit initially because it's a one-time compression. But once it's there, then you're in good shape. So I haven't tried it. I don't know for sure, but it's a small possibility for it to say, for example, export a bunch of text data from mainframe and import it as BCP. That it's a possibility you might have a little hit in performance during that import.
So the migration always has got some transformations in between. We can't do BCP there.
Yeah, so I can't really answer the question 100%. I don't know because I've never tried that particular configuration. But again, once the migration is over, you're not have a problem. It's just during the migration, I know it depends upon your circumstances of the migration. I wish I could. You might try. There's another session right after this one by Colin Millichip, and he's talking about the technical details of this product, and he might be able to answer that question a little bit more easier than myself. Mine's more of a non-technical presentation. Yes, sir.
I do a lot of sessions on compression.
Okay.
So questions I'm happy to help answer.
Okay. We'll work with migration one a little bit later. I need to focus on it, getting the rest of my stuff done, but at the end of the session, though, we can talk more about it if we want to. Okay. So we talked about that compressing duplicate databases. Let's talk more about compressing backups. And of course, most of you probably are familiar with this. So my question should be, is who is not using backup compression? Okay, not very many of you. So which is good, because backup compression has been around a long time. It's a proven technology. But again, I do want to talk about it a little bit more here, and specifically mention SQL Backup Pro, because I imagine most of you using a variety of different compression. You're probably using, some of you using native SQL Server compression, some of you probably using Lightspeed, or some of the other third-party products. So I want to give a couple examples how SQL Backup Pro does it, because it has a couple of neat little features. I demonstrated some of them this morning in my first session that are kind of handy. But compression is higher on SQL Backup Pro than it is on SQL Storage Compress. Why would you think that might be? We can actually compress backups more than we compress the database.
Different algorithm.
It's a different algorithm, but it's another reason too. It's actually an intentional reason. Actually, we're purposely not compressing as much as we could. The reason for that, in my presentation this morning, I talked about the fact that if you have auto-grow on your databases, you have auto-grow, constant kicking in, it will contribute to index fragmentation, which can slow down your system. Well, obviously, when you have a compressed database, we have no extra space. So what we've done, though, is we actually have created extra space. Rather than compressing it as small as we can, that way any change would force files to be created larger and fragmented, we actually have empty space, kind of like an equivalent of a fill factor inside it. It's not saying exactly, but it's kind of the same concept. So as you doing data changes, modifications, and whatever, it's not always going out there and increasing the size of the file. Of course, sometimes it would have to if you add a lot of data. But your normal everyday stuff, like an update would never do anything, delete wouldn't do anything, a select wouldn't do anything. The only thing that would increase the database would be a whole bunch of inserts. So we've actually not compressed it intentionally as much as we could compress it. But obviously in backups, which we don't have to interact with, we compress it as much as we can. So we get up to 95% compression, typically about 80. Actually, most cases I've done it, I get about 83 to 85, based on my experience, but it will vary upon the nature of the data that you have. If you have images stored, for example, or binary data, it's pretty much uncompressible because it's already compressed. But if you have character data, it compresses very quickly and very easily. SQL Backup Pro also offers some advantages over native compression. For example, we have more options in terms of compression levels. In other words, you want to spend more CPU time, you can get higher compression. You also have, of course, reduced backup times and reduced restore times. That's always a key thing besides the reduced backup size, of course. We can also add encryption, which is something you can't do in native SQL Server. The only way to do it in native SQL Server is to add transparent data encryption, which is the enterprise option, then do a backup, then you'll have encrypted backups. But again, this is nice to be able to click a switch and it does it automatically. And that's one of the best practices I always recommend is always encrypt your backups, because if a backup gets lost somewhere or stolen, people can get your data right away. Also, SQL Backup Pro offers centralized administration. So rather than, you could have one control panel and all your servers can be managed from one location, rather than worrying about going to each machine or logging on each machine and going to SQL Server agent and creating jobs and managing jobs separately. So that's kind of nice. And we have the new feature, which I talked a little bit about this morning, backup verification. So when you do a backup, you can also schedule a restore. So we'll do a backup and take that backup, automatically restore it to another machine to verify that it's good. And even run a DBCC check DB on it if you want to, which is kind of a nice little feature. If you want to really verify that your data is working the way it's supposed to, which is, of course, you want backup to work.
What is more? You said and much more.
I'm sorry?
You said and much more. What is more?
Oh, more features? Well, I could list a whole bunch of them. Probably the easiest way is to talk to one of the salespeople out in front. They'll tell you all the options. One example is the GUI interface, a much better GUI interface. I'm mostly comparing this against a native backup compression. I don't know all the other third-party vendors and all the pros and cons of what they have. Everybody uses the same technology, too. I don't know if you're aware of that. We use it, same technology, basically Lightspeed use, and all the other ones use, because Microsoft creates this API that we can use for backup compression. And everybody uses the same API to do it. It depends what algorithms they decide to use, what kind of GUI interface they want to add. That's basically the differentiating features between the products. This is a real obvious example. I just wanted to mention it just because, again, it may not hit you hard enough yet, but I'm going to hit you, emphasize again the importance of how much money you can save. Let's say we have a terabyte database. Let's say we're keeping 2 weeks of backups. The reason I chose 2-week backups was that's what we used to do at our company. So I know that's a valid number some people use. And that's 14 terabytes of backups. That's a huge amount of stuff. And that's very expensive to store. Traditionally, a lot of people store that in tape, which is obviously cheaper than SAN, but even tapes is not cheap. I think our tape system was a 2,000 cartridge robotic backup storage system. It's well over $1 million. The tapes themselves are very expensive, and as you know, they wear out and have to be replaced periodically. And we had like a full-time backup administrator, and we had a service contract and everything else. So actually storage is still pretty expensive. Not expensive as much as a SAN, but it's still very expensive. But again, it's 4 terabytes. But with compression turned on, we turned that 14 terabytes down to 4 terabytes. So if you store it in SAN, you're saving huge numbers of money. If you store it on a tape device, it won't be as much as that, but it's still going to be a heck of a lot more than the cost of the product. So compression is always a win-win situation for everybody. So I think most of you probably already know that, though. But this is the kind of stuff you can go to your boss saying, we're not doing compression now, we need to be doing compression because it's going to save us a lot of money. And I want to do a little demonstration. If you were here this morning, you saw the same demonstration. So it will be a duplicate of what you saw, but I'll go through it again real quick. I'm just going to take one of these databases and kind of go through the GUI interface. You don't have to use the GUI interface. If you're one of these kind of people who prefer code, you can just all encode too, just as easy. And actually, that's what I do. I prefer to actually use code, but it's easier to demonstrate the GUI than it is to do all the code, especially if you don't read T-SQL. But I want to show you some of the options that are available. This is a centralized administration panel, and then I can right-click. Actually, I don't want to right-click. I'm going to go up here and do a scheduled backup job. And I'll back up my machine, of course. And you can do standard things that you see in any backup application. This is a normal SQL server. You can choose full, differential, transaction log, whatever. You can also do copy-only backups. Choose which databases you want to back up. Because there's always scheduling, that's pretty normal. I'm just going to choose something real quick here. Because this is stuff you've all seen. I want to show you a couple things that are different. This is one of the things that's kind of unique. You don't get this in a lot of the other products, especially the native SQL Server. It's copy backup to network. What that is handy for is once the backup's made, and it's probably made on a local device or SAN or designed for backups, then what you can do is it will, as part of the job, once that's done, it will then take that copy and move it somewhere else. You can move it to a disaster recovery facility, or can move it to another server where you actually do a test restore, which I'm going to show you how to schedule one of those automatically. And you can do actually multiple copies. You can, yes?
One tiny question. I mean, in the previous screen of the GUI, you have user backup, system databases and all that.
Mm-hmm.
What if we add an extra database and you select all the user databases? Will it automatically include
Yeah.
them all?
Yeah. The question is this, if you add more databases and you say all databases, they'll automatically include it, just like it does in native SQL servers the same way. The maintenance wizard doesn't do that. As you know, it can be problems with that, but it's not normally a problem. Okay, so the copy back to network is a nice feature. And again, it's something that you'd want to use if you were trying to use the automatic restore feature, which I'll talk about in just a moment. But I don't need to show that now, so I'm going to turn it off. The other thing I like to show is, again, we have 4 levels of compression. Native compression only has 1 level of compression. And what you can do to see how much money or space you can save is you can run this little tool, and it'll take a minute or two to run because it has to go through your entire database. Of course, you don't have to go through the whole run if you don't want to. You can just go through part of it and get a pretty good answer. But it tells you how much actually compression you'll get and whether it's worth or not to choose a different level, because the higher compression level you choose, the more CPU is going to be used. So if you have a machine that has lots of CPU, I would choose number 4. But why not? But if you have a machine that's CPU bound, you might want to choose less CPU. But as you can see, level 1, it's going to end up being 42 meg. Level 4, 24 meg, just about half, or just slightly more than half. So it's quite a bit difference. Think about it. Of course, in this particular example, 20 meg's not much, but talking about terabyte or 5 terabyte database, the extra compression is going to save you a lot of space. And this is something you can't do with native SQL Server compression. We just have one level, which is pretty much equivalent to our level 1. We have other options like how many threads you want to devote to it, speed it up, or we use more or less. My machine actually has 8 cores. It automatically uses 1 less than that by default, but you can change it more or less depending upon your server. And we can also choose the checksum and the verify options, which are kind of nice to do when you do backups to help determine the integrity of your database backup. Again, it's not a guarantee it's going to work, but it's better than doing nothing. Of course, the best thing is to restore it, which I'm going to show you in just a moment. And so it's done. So I'm going to cancel that. But now I want to show you the other side of it, which is a neat feature. This is the only product that has this. And this was my idea. I talked to the team into actually adding this feature. And that is to automatically schedule a restore. Because again, scheduling a restore is the only way to definitely guarantee that a backup will actually work. But it's a pain in the neck to set up. So I said, can't we automate this some way? And he said, eventually, it took a couple of years of asking and asking, and he finally said it. So they created this wizard that I can start up, and it would pre-populate a lot of the information for me. Of course, the destination server would be a different server than mine, so I'm kind of cheating here because I only have one machine. We'll specify the database, where the backup is, and then it will create a database usually under another name, because that way you don't get confused, right? And also, typically you want to overwrite any of the ones that happen to be there because you don't want to have multiple copies. But typically what happens though is if the restore is successful, it will delete the copy. And that way you don't have to worry about the server getting too big and full and things like that. And then I'll choose next, and then it's the location where you want the files to be stored. That's easy. And next. And then another thing besides doing the checking the restore, then you can optionally do a DBCC check DB on top of it. That way you can offload that activity from the production server to another server. As you know, DBCC check DB is very resource intensive, and because of that, it's nice to be able to offload it off your system rather than run on your current system, because again, it uses a lot of resources. And so what will happen is when it runs, everything works great. If you want to, you can have an email sent to you on success. Probably not necessary, but what you can do instead is drop the database. Actually, unsuccessful, which we want to leave it, I guess, because if it fails, you would get an email saying it failed. That way you want the database on there so you can figure out what's going on. And so again, it's a nice feature. And then also when it sends you the email and it logs the information, it will log you all the information from the DBCC command itself. When it runs, it creates a huge amount of information. And most of it's saying that everything's okay. But if it's anything bad, it will tell you all that's bad. And all the information will be logged and actually stored in the log files, which actually be on here once after the job actually ran. You can see it here. You could right click. If it said failed, and it'll show you all the log information. So it's kind of a handy feature to have. So if you haven't tried out SQL Backup Pro and you're using some other vendor, you might think about using it because of all the cool neat features that it has. And as you know, Quest Software just got bought by Dell Computers. Did you know that? Yeah, Quest Software just got bought by Dell. And it's a possibility some of the Quest tools may no longer exist shortly, because Dell is going to take the best of what they want and integrate it into the system. With tools they don't like, they're just going to drop. We don't know if Lightspeed's one of them or not, but it's actually a candidate because it's not a big growing market. So keep that in mind, back of your mind. If you're using Lightspeed now, you may want to check your your vendor and ask them if Dell intends to continue supporting the product for how long. I'm sure they will for a while, but they may not innovate on it. They may just kind of leave it like it is until they decide at some point to stop supporting it, but who knows. But a number of Quest products will be going away. You just don't know which ones yet. That just happened last week, I think. Okay. So I'm essentially done. I'm going to kind of summarize a little bit what we talked about. Again, obviously data is growing a lot. We know that. In 5 years from now, it's going to be 8 years from now, it's going to be about 50 times more than it is now. That's just a huge number. So we're going to have to start dealing with it right now. And obviously, dealing with this data duplication, database duplication, is one of the key things that we can deal with now. Backup compression, again, most of us are already doing anyway. If you're not doing it, you need to be doing it. Can save us money right now, and of course, obviously money in the future. It means it's going to be building on itself as data grows and grows, and something that you want to probably consider. So again, what I'd like to suggest is you go back next week, look at what you're doing, first of all, with backup compression, and see if you're taking full advantage of everything you need, and how's that working for you. And then again, start thinking about what you could compress in terms of non-production databases. And download it and do a trial copy. Go get a test machine, put it on your laptop, and get one of your production databases and put it on it and see what happens. See how much it compresses. Start playing with it. Try to break it. If you can break it, let us know, because I haven't been able to break it yet in my machine at home. I've been trying to, but I haven't been able to yet. There's one little bugaboo, though, I did want to mention, is that SQL SQL Storage Compress has an optional GUI. It's not required. I never use it, but it's not compatible with 2012. It actually loads, but the screen doesn't look right. And we're working on that, but it works in 2008 R2 or earlier. So if you try and try it out, and you happen to load a GUI, which is not required whatsoever, it's just put there basically to show you what the compression ratio you'll get, and make it do a very simple compression. But it's a very small thing. But I might mention that if you download it and try it out. But again, it's easy to go ahead and use code, and you use the exact same code you use for T-SQL. When you back up database, you use backup. Actually, to compress the database, you use restore. It's very simple and straightforward. Some more information I've done. I did some study already, and I wrote an article on SimpleTalk website called Bradshaw Guide to SQL Storage Compress, which explains how it works internally, technically, and also a whole bunch of testing that I did. And I compared it against non-compression, native SQL Server compression, and SQL Storage compression. And this is actually based on an older version of it. I'm actually currently writing a newer version of this based on a slightly updated, improved version of SQL Backup, SQL Storage Compress. And also the article on SQL Backup Pro for the accidental DBA, that was written by Grant Fritchie. This is also on SimpleTalk. So what kind of questions do you have, if anything we've talked about? Yes?
One question. The storage compress, data compression won't compress log data. Whereas, so we are actually using the storage compress to actually have even when you're using data compression, we're actually using storage compress as well to effectively deal with the log data to be compressed on disk.
Yeah.
So that's one area that it helps.
Yeah, I'm going to mention, and just in general, is that what some people are doing is they're using native SQL Server compression plus SQL Storage compression together. That's because native compression only compresses indexes, clustered, non-clustered indexes, and also will not compress any other objects, and also will not compress log objects. But SQL Storage Compress can do all that. Even the file stream stuff it can compress for you. Of course, a lot of that stuff may be already in a compressed format anyway. You won't get a whole lot of benefit from it. But again, it would do better than you would without doing compression. You'll get some benefit from it. Depends on the nature of the data. Any other questions?
Any way with compressed data like you do with normal data? Because I've not used it, so I don't know.
What do you mean by normal data?
Well, if you compress a database, a production database, can it still use just normal?
Oh, yeah. It works identical. Nothing different whatsoever. You wouldn't even know it's there. As I mentioned earlier, there's some people who've installed SQL Storage Compress, they downloaded it, installed it, followed the instructions, and they call us up and say, it's not working because I'll look at on Management Studio and it says it's not compressed. That's because, again, it's all hidden in SQL Server. If you go look at the actual data like I showed you, the physical files, you can see they're compressed. But SQL Server does not know it exists. All the compression occurs at the operating system level using Microsoft APIs. So it's all hidden away from SQL Server. So nothing has to be changed. You just load the service, and then you have to go through a process basically where you restore a backup. When you restore the backup, that does the initial compression, and from then on, you just act as a normal database. Any other questions? Okay, I'm not sure if I answered your question 100%. Did you ask, can you run DBC check DB on a compressed database? Yes.
So, like 80% time, if I use native DBC check DB, it takes 1 hour. They use your tool, the prediction in the execution time.
Yeah, it works identical, and there's no issues with it whatsoever. It works perfectly. Yes.
Are there any provide performance counters or anything that you can see? Say, for instance, you did have a performance issue, perhaps with disk I/O. He wants to check whether it's actually disk use or whether there's something in the compression that's actually slowing down. You've got contention within that.
Okay. The question was: is there any kind of like a built-in counter that you can use to evaluate? No, there isn't. But what I've been doing is I've been using the performance monitor counters and doing trial. For example, what I will do is I'll say take a non-compressed database. I will select 5 million rows from the database, and then I'll use several performance counters like CPU, disk activity, disk latency, a bunch of those kinds of things, and then I'll compare it to a compressed database, doing the exact same operation, and then comparing the difference between the two. And you look at it, you'll be surprised how close they are. It's actually, if you look at the graphs on the performance monitors, it's almost impossible to tell the difference sometimes because, again, you collect data once every second kind of thing. You lose a little bit of detail anyway. And you start comparing them on top of each other. They look almost the same. I mean, it's only about 0.5% CPU use additional, so it's very, very minimal.
So you're going to see the same number of reads and writes?
No, less. Well, okay, that's interesting. In SQL Server, yeah. Right. In SQL Server, if you go like to DMVs that tells you about reads and writing stuff, yeah, they'll look like the old numbers. But if you use the performance monitor counter stuff that looks at from the OS side of things, then you will see it. That's another tricky thing you have to remember. Some people forget that and they say, oh, it's not working. Yes, it is working, but you have to look at the OS stuff. You can't look at the SQL Server stuff because it's always fooled. Yes?
Is there any problem if the compress hang in the middle, for example? Hang up in the middle? Stop or crash?
Compression fails in the middle.
Oh, I've never seen it. Again, we're using Microsoft's APIs to do this. So if it goofs up, then Microsoft's done something wrong. Oh, what would
happen? Sector, bad sector, or anything?
Oh, then it would behave just like.
Any rollback?
Oh, it would be, yes, it would work identical like it does now because it's done at the operating system level. So if SQL Server is doing its thing, it's reading data or writing data to the hard drive, the data crashes. Well, it'd just be like at any time of crash. So you have the log would roll back or roll forward as appropriate when the server came back up. Compression is completely separate because all the rollback and transaction consistency is done within SQL Server.
Doesn't affect the online data, I mean the people connected now?
No. Again, keep in mind that all the compression is done in the OS. Everything in SQL Server is kept separate. SQL Server works identical to the way it does before. It doesn't even know the compression exists. And because of that, that's just hard to get across sometimes and grasp, is again, completely separate things, but they work underneath the surface for the compression to occur. So you have to change any behavior what you're doing now. Well, we're out of time. So thank you very much. If you have any questions, I'll be outside and be glad to answer your questions. Any more? Thank you.